So our goal tonight is to cover two mini topics, and let's dive right in. The first one we're going to title is bases other than e being our exponential number, of course. So here's our rule, the derivative of a to the x, and I only want to make one small note in our book here, is that a must be a constant, and this guy's derivative is a to the x times the ln of a. Okay, now again, just picture your favorite constant. Maybe this function is 2 to the x, or maybe it's 10 to the x, whatever your favorite exponential function is, there are bases other than e. And here's the rule, it's a to the x ln of a. Now, that's clearly if my rule is very specific. Let's say I had a lot more junk up there. Let's say I had a to the u. Okay, and again, u is some function like x squared plus 5x. This is a to the u times du times the ln of a. Now, you might be thinking, oh my gosh, my head's going to explode. I can't remember one more derivative rule. We've just got way too many. I just want to show you this is basically the same rule as your exponential rule. Watch this. The derivative of e to the u, well, we all know, is e to the u du. Now, that rule is almost exactly the same as this one, right? We left our a to the u, we took our derivative of u, we only have this extra piece, the ln of a. Now, I actually do have that in my rule here. I do have the ln of my base e, but we all know the ln and e zap each other out. That's why we don't see it in the rule, but it is technically the exact same rule. The e is just canceling with the ln here. All right, so one more time, you leave it alone, you take the derivative of the exponent, and I just want to be clear, you're taking the ln of the base of that constant number. So let's take a look at these two equations. Number one. Now, again, if you're getting overwhelmed, the first thing I like to do is just identify what type of function I have, and that should take care of what rule to use. So when you stare at this, I mean, you've got to see that you have an exponential function. That's the first thing that should pop in your head. All right, and why is it exponential again? Well, again, we have a number to a variable. So like e to the x is exponential, and that exponent is a variable. So I'm just going to follow the rule we just talked about. I'm going to say y prime equals, leave it alone, just like we do with our e rule, times the derivative of the exponent, so times 1. And then that one extra step is the ln of the base, so times the ln of 2. And that's it. Okay, now they certainly could move the order on you, but that's essentially what we should get. Example 2, same idea. Again, does exponential spit out at you? You have a number, a constant, raised to a variable. X is clearly a variable, tangent x. So just follow the rule. Leave it alone. Derivative of the exponent, so times secant squared. And then, of course, times the ln of the base, ln of 2. Next example, write the equation of a tangent line to the function f of x equals 6 to the x minus 3 at x equals 3. So it wouldn't be a calc video without writing the equation of a tangent line. Let's go ahead and get the two things we need. I first need my y value, so I'm just going to evaluate f of 3. So I get 6 to the 3 minus 3, of course, is 0, and anybody to the 0 is 1. So I know my point is 3, 1. And then I need to go get my slope, so I need to take the derivative. And hopefully you can pay attention to that rule. Again, we have exponential, we have a constant to a variable. So that rule, remember, is leave it alone. The derivative of the exponent, so times 1, times the ln of 6. And then I'm going to carefully evaluate f prime at 3. I need my slope at 3. So I get 6 to the 0 times 1 times the ln of 6. And of course, 6 to the 0 is 1 times 1. I just get the ln of 6. Putting it all together, it looks like my equation is y minus 1, the ln of 6, times x minus 3. And again, I don't know the ln of 6. We're just going to leave it there and say we're good to go. Alright, well, I've got 4 quick examples for you, and if you can decipher the difference between each of these, you're probably in pretty good shape to move on. So what I want you to do is label them 1, 2, 3, 4 in your notebook, pause it, see if you can identify what type of function you have, and then apply the correct derivative rule. So take 3 minutes, pause it, identify what your rule is, and take its derivative. So hopefully we didn't cheat ourselves here. We're here to become better at what we do. Number 1 is probably the bear trap in there. Hopefully you caught it. E, remember, is a number. Remember, E is approximately 2.718. And I basically have a number to a number. Well, that's just a bigger number. I would say its derivative is 0. I want to be clear that this represents just one big constant. Alright, so bear trap number 1, hopefully you didn't fall for. Number 2, one of the most famous derivatives, e to the x. The derivative of e to the x is simply e to the x. Number 3, very similar to my exponential function, but my base is not e, so it requires that extra step. Remember, we leave it alone, 4 to the x squared, the derivative of the exponent, so times 2x, and then, of course, the ln of 4. And lastly, number 4, maybe another one that might make you nervous, but I think it's very simple. Remember, e is an odd number, so if I said y equals x squared, could you easily take its derivative? Probably everyone can do that pretty fast. But when I throw an e up there instead of a 2, it makes people nervous. It's the same rule. E is just a number. So its derivative should just be e times x to the e minus 1. Remember, e is just a constant. Alright, well now that we know that rule is pretty straightforward, let me just show you where little bear trap may fall on our AP exam. So let's go ahead and take this derivative real quickly. I get y prime equals, leave it alone, 3 to the 2x times the derivative of the exponent times the ln of 3. Alright, now you might be thinking that's pretty straightforward. I haven't seen a bear trap yet. However, here's where the trap comes in on the cleanup. Sometimes that won't be a choice. And my whole idea here, and I want you to start this in your notebook so you don't fall for it, is you might have to clean up with log properties. Alright, we might have to clean it up with log properties. And what do I mean by that? Well, remember, this 2, I can actually move up to the exponent. So I could say this derivative is actually 3 to the 2x times the ln of 3 squared, or which is obviously equivalent 3 to the 2x times the ln of 9. So be real careful. If you don't see your answer, you probably didn't do it wrong. It's just the AP gets a little sneaky with its cleanup, so think log properties. Alright, so that leads us into our second topic tonight. Bases other than e, specifically logarithmic bases. Alright, now, I'm not going to teach you anything new because you should have talked about this in Algebra 2 trig. Alright, so the derivative rule might be a little new to you, but the idea behind it is straight from Algebra 2. And that's called the change of base rule. Okay? So let me refresh your memory on that change of base rule. If we say log base a of x, we can use change of base and say that's equivalent to the log of x divided by the log of a. Okay, now, do I have to use logs? Well, no, you can actually say that's equivalent to the ln of x over the ln of a. That is okay as well. Alright, but this is the change of base rule. Maybe what you need to say to yourself is the base, that's the base, the lower number, always goes on the bottom. Okay, keep saying that to yourself if you get stuck. The base goes on the bottom. Now, notice this isn't natural log, so I can't just use my du over u right away. I had to rewrite it with change of base. So let me just switch the letters on you real quickly. If we said y equals log base b of z, my first move before I thought any calculus would have to be to rewrite this as the natural log of z divided by the natural log of b. Alright, so that's going to be our first move when we take this derivative. Alright, so let's start with the generic rule. The derivative of log base a of x is equivalent to, and here's where we need to rewrite this. Okay, so it's key that we rewrite. We're going to use the change of base formula and say this is equivalent to the derivative of the natural log of x divided by the natural log of a. Okay, so let's make a note. The first thing we did was rewrite. Now, one of the most important things to remind yourself of is that this base a is a constant. And because a is a constant, therefore the natural log of a is also a constant. Okay? So again, my base is a constant, therefore the natural log of a is a constant. Which tells me, that makes this easier, I can avoid quotient rule because this is just a number. I could say this derivative is actually 1 over the ln of a times the ln of x. Okay, now 1 over the ln of a is a constant, so I just want to be clear, that just comes along for the ride. That's my coefficient. Alright, we're just going to bring it along for the ride. So I actually get 1 over the ln of a times the derivative of the ln of x, so times 1 over x. And ladies and gentlemen, that is my final answer. So let's just practice a couple together to make sure we're feeling confident. So the first thing I do is I avoid calculus and I just rewrite. Remind that to yourself. We are just rewriting. And I'm going to say this is equivalent to the natural log of cosine divided by the natural log of 9. And I'm going to rewrite it one more time because the natural log of 9 is just a constant. It's a number in front. So I'm going to pull it out as 1 over the ln of 9 times the ln of cos x. Okay, I've done zero calculus. I've just rewritten this twice. Now let's do the calculus. Y prime equals, remember this is just a coefficient, comes along for the ride, 1 over the ln of 9 times this guy's derivative. Well, ln's are du over u. So if my u is cosine x, my du is negative sine x. And ladies and gentlemen, that's it. That may not be an answer, you could say the negative sine over cosine is actually equal to negative tangent of x. And if I multiply the bottom over the ln of 9 to clean it up a little more. But that is simply my derivative. So let's call this one the last one for tonight. Again, I want to rewrite it. So why don't you pause it, try it on your own, see if you can rewrite it and see what I get. So I would say I get, oops, not that. I would say this is equivalent to the natural log of x cubed minus 2x divided by the natural log of 4. And I'm going to rewrite it one more time to say that's 1 over the natural log of 4 times the natural log of x cubed minus 2x. Alright, so at this point I've done zero calculus, I've just rewritten it. Now I've got one quick derivative. Remember, this is just a coefficient, 1 over the ln of 4, times, this is a quick du over u. My u is x cubed minus 2x, so its derivative is 3x squared minus 2. And again, lastly, I'm just going to multiply it to put it together. I would say on top, I've got 3x squared minus 2 times the ln of 4, or divided by times the ln of 4, x cubed minus 2x. And there you have it. That is our simple rule for the night. Well, hopefully that's enough examples. If you have any questions, we'll see you in the morning.